Hello, this is Mr. Wyrick. I'm here to talk to you today about Lesson 13.3, Geometric Probability. We've been working on probability. We talked about permutations, combinations, and sample size, or sample area. So what we're going to do now is we're going to talk about geometric probability. This is going to kind of end where we talk about this chapter. We're going to get to the mid-chapter exam, then we're going to start doing some review of older geometry concepts leading up to our final. When it's geometric probability, that means we're still calculating probability, the odds of something happening, but it involves length or area, some kind of geometric measure. So the first one that they mentioned is length probability. It's on page 391. If you need to take a look at what they have, I've got something similar here. So we've got a line AD, or a line segment AD, and we contain within that another segment BC. So if we pick a point at random, remember that a line or a line segment has an infinite number of points. So we can't just say, well, there's 16 points on there, so if we pick one, it's going to be 3 out of the 16 are on this line segment. It won't work that way. So what we have to do is take measurements of their lengths, and we would say the probability of a point at random being contained in BC, if it is on AD, would be the length of BC over the length of the entire thing of AD. Okay, it's a little different than one of the other scenario that we're going to look at, but remember, you just measure this. So if this is, we'd say 1, 2, 3, 4, 5, about 5 inches, and this is 1, 2, 3, so maybe 6 inches on this side, and maybe 7 inches on this side. We'd say 13 plus 8 would be 21, and on the middle there would be 5. It would be, your probability would be 5 out of 21. Now the odds of it not being on BC then would be all of the rest of it. Okay, so, I'm sorry, that's not 21, that's 18. 5 out of 18. Okay, so the odds of it not being on there would be the remainder, would be 13 out of 18. Okay. On the other side of it, our other scenario that we're dealing with, again, we're talking about area probability, and in the area of this, there's an infinite number of points. Again, so we can't just say this is like picking people. We've got 6 people that we have to choose, and we have to choose one of them. If we choose at random, it's going to be 1 out of 6. We can't do that. So again, we're doing area. If we pick a point at random, the probability of it being in circle B, if we pick an area, if we pick one that's in rectangle A, again, we'd find the area of B, we'd find the area of A, we'd put the area of B over the area of A, and say this is our probability that it's going to be inside this circle. Remember on these, especially if it's concentric circles or any kind of circle within a circle that you're trying to figure out the probability, make sure you reduce. If you leave it in terms of pi, it's going to be easier. If we have pi over 9 pi, it just reduces down to 1/9. If you've got any kind of fraction like this one over here, the 5 over 18, if that would reduce, if it had been 6 out of 18, then we would have reduced it down to 1/3. When you're doing probability, it's almost always expressed as a fraction, sometimes as a decimal, sometimes as a percentage, but usually a fraction. So it's important to reduce that. If you ever take a look at the Las Vegas game of roulette, you can see they've done some reduction of fractions with how it pays out for the different spins. In this case today, there's not just a ton of different kinds of problems. It's mostly you're finding the area of different things and you're putting them into a ratio. So what I would like you to do, problem 6 all the way through 36. And again, as we move forward from this point, we're going to be doing some review of some older geometric concepts, but we will have a review and the mid-chapter exam for this chapter. If there was anything you didn't understand from this lesson, from some other lessons, make sure you come in during tutorial time. You show up during class, you're ready to go. You ask those questions, and I will try to help you out. And we'll see you then.